All right, listen up. This is an emergency briefing. We have an extinction-level threat on a direct collision course with Earth, and sitting around and waiting is just not an option. Our objective is something that's never been done before. We are going to destroy a black hole.
Let's be perfectly clear about what we're up against. The stakes? They couldn't be higher. Failure means the end of, well, everything. So our mission is simple and direct.
That's it. Our only course of action is total annihilation. We take this thing out no matter what it takes.
Okay, let's get into it. First up is our initial plan of attack. Good old-fashioned, overwhelming brute force.
Yeah, you heard that right. Plan A is to gather every single nuclear weapon on this planet and fire them all at once. This will be the single largest coordinated strike in the history of humanity. And just so you understand the scale of what we're talking about here, that's the combined energy of 425,000 times the bombs dropped in World War II. I mean, it's an unimaginable amount of force. This has to work, right?
Well, mission update. Plan A was a complete and utter disaster. The black hole didn't even flinch. It just ate the nukes. It literally consumed all that matter and energy, and now it's even bigger. Turns out what doesn't kill a black hole makes it a whole lot stronger.
Okay, so clearly just throwing things at it isn't going to work. We need to be smarter. We need a new strategy. And before we try anything else, we have to understand what we're really dealing with. You know, as Sun Tzu said, know your enemy.
So what is a black hole? At its core, it's a spot in space-time that's so incredibly dense, its gravity is, well, it's absolute. Nothing gets out, not even light. And here's the kicker. Our galaxy is probably crawling with them. We're talking an estimated 100 million.
And they're born in a couple of different ways. Sometimes a massive cloud of gas just collapses in on itself and poof, you get these enormous supermassive black holes. The other way is when a giant star goes supernova and its core collapses. That leaves behind a smaller, stellar mass black hole. We have to be ready for either type.
This leads us to something called the event horizon. You can think of it as the ultimate point of no return. It's the boundary line. Once anything crosses it, anything at all, it's not coming back. Ever. So, what happens if you do cross it? Well, scientists have a pretty vivid name for it: spaghettiification. The gravity is so intense it would stretch you out like a noodle while squeezing you at the same time. Yeah, not pleasant. Let's try to keep all our assets far away from that.
You know, for all their complexity, black holes are actually defined by just three simple things: their mass, how fast they spin, that's their angular momentum, and any electrical charge they might have. That's it. And these three things have to stay in a very delicate balance for the black hole to even exist. Keep that in mind. It might just be a weak spot.
All right, intel gathered. It's time for a new plan of attack. Since throwing nukes at it was a bust, we've got to get a little more exotic. We're going to fight fire with fire.
The new plan? We build our own black hole, but out of antimatter. Theoretically, here's how it works. First, we accelerate protons to almost the speed of light. Then, we slam them into something like iridium. We collect the antiprotons that fly off, focus them, and boom, you've got an antimatter black hole. Then we just toss it at the other one.
Mission update. And it's another failure. When our antimatter black hole hit the target, it created this massive explosion of pure energy. But the black hole just sucked it all up. It basically had the explosion for lunch, and now, you guessed it, it's even bigger.
Okay, we're starting to run out of ideas here, which brings us to a purely theoretical idea: the white hole. It's the total opposite of a black hole. Instead of pulling things in, it violently spits everything out. If you could smash one into a black hole, in theory, they might annihilate each other. The big problem? We're not even sure white holes are real, and we definitely have no clue how to make one. So, this is a dead end.
All right, we've tried brute force, we've tried exotic munitions, nothing's worked. It's time to think way, way outside the box. We are now entering the realm of fourth-dimensional warfare.
Now, this is going to sound like something out of a movie, but hear me out. What if we could use a wormhole, you know, a tunnel through space-time, to connect the black hole to its own past? You could theoretically force it to spit out everything it's ever eaten, essentially turning it into a white hole. It's a cool idea on paper, but yeah, we don't have a time machine or a stable wormhole just lying around, so another no-go. Okay, how about this? Since not even light can escape, what if we made a weapon that's faster than light, an FTL bomb? If you could detonate that on the inside, maybe you could blast it apart. The tiny little problem, we don't have a faster-than-light bomb. Yet.
Right. So, every attempt to just blow it up or get clever with space-time has failed. It's time for a totally different tactic. Instead of a head-on attack, let's go after its foundation. Let's see if we can deform it.
Hey, remember those three things that define a black hole? Mass, spin, and charge? Well, it turns out for a black hole to stay stable, its spin and charge have to stay inside a very specific range, this green zone here. If we can somehow push them into the red zone, its whole structure could collapse. So if we can spin it too fast or maybe zap it with too much charge, we might just be able to tear it apart from the inside.
Look, so far, every single thing we've tried to do has either failed or is just science fiction for now. That brings us to our last option, and it's actually the only one that's scientifically plausible. It doesn't need weapons or time travel, just a whole lot of patience.
As it turns out, black holes aren't forever. They actually have a built-in self-destruct mechanism. It's a process called Hawking radiation. See, right at the edge of the event horizon, tiny pairs of particles are constantly popping into and out of existence. One particle falls in, but the other one escapes, and it takes a tiny, tiny bit of the black hole's energy with it. It's a very slow leak, but over trillions and trillions of years, the whole thing will just evaporate.
So, can we destroy a black hole? With the technology we have now, the answer is a hard no. A force of nature this powerful is, well, it's pretty much indestructible on a human timescale. And that leaves us with one last, pretty sobering question. If our mission to destroy it is impossible, maybe we have the wrong mission. If we can't destroy it, could we escape it?